Hello, my name is Prachit and welcome to my channel. So in this video, I'll be talking about the millis function, how to use it in Arduino. I'm using here Arduino Nano. I've connected one LED to pin 2. I've connected the Arduino Nano to the COM port. I've opened the Arduino IDE, created a sketch with name called millis tutorial. So let's get started. So when you want to blink a LED, we give a delay using this delay function. And this type of delay function is actually a blocking delay. And you don't want to use this when you want to do multitasking like read from a sensor, simultaneously blink a LED. And the delay function, what it does is it actually halts the program in this line. On this line the program stops. That means whatever written here is not executed. Okay, the program stops here for exactly the time we pass here. Suppose we pass 1 second, so the whole code stops for 1 second, and that's a drawback. Suppose there is a watchdog timer, then the board will reset. So watchdog timer is triggered, and to avoid that situation we use the millis function. So the millis function returns us the counts which are incremented with a delay of 1 millisecond. So very soon it will reach a very large number. That's where it's returning an unsigned long data type. So we'll store it in T. The millis will return us the count. So even if we don't call the millis function, the microcontroller is fed with a crystal oscillator frequency, which is incrementing the timer register. And whenever this timer overflows, that means it goes from the maximum value to 0, it increments a count. And that count is returned to us by the millis function. So imagine like we have access to a 32-bit register which is getting incremented with a delay of 1 millisecond. And we can tap to it anytime we want. It's like a timer which starts when the program starts. And using this function, we can tap into that count. So let me print this on the serial monitor and show you what I meant by that. I'll let serial.begin. Baud rate is 9600. And print this T on the serial monitor. We'll upload this program to the Arduino. If you're new to the Arduino IDE, just download it from their website and get yourself an Arduino board. Just connect it and figure it out by watching other YouTube videos. There are a lot of videos. You can download any IDE. I'm using here 1.8.18 version because I'm programming since 2016. So done uploading, and I will open the serial monitor. You can see the count starts to increment from 0. So this count will reach to a very large number. That's why it's returning millis function uses unsigned long. So it's 32-bit. The size of unsigned long is 32-bit. So 2 raised to 32 is the maximum number. So at the rate of 1 millisecond delay, this count will reach 2 raised to 32 after 50 days. So if you are using the millis function to keep track of time, then it's a good idea, but you have only 50 days. And also you want to keep the board powered on for 50 days. So let's implement delay using the millis function. Now you understood how to tap into the counts using the millis. So now we want to implement a logic which uses this flow of counts to make a delay. So let's first define our LED. Int LED is equal to 2. It's better to write const. And now we need a variable called previous val. And initially we will keep it 0. And LED is output. So write LED comma output. And in the void loop, what I will do is I will declare current val. So this will increment with a delay of 1 millisecond from 0 because there is no delay in the void setup. And in the if condition, we will write whether cur val is greater than 1000, which is our time. So let's store this 1000 in a variable TP, time period. So when cur val is greater than TP, we will toggle a state. So the state is a boolean variable. So we'll write bool state is equal to false. So initially false means low. So initially state is false, it will toggle, and now it's 2, the LED will turn on after 1 second because TP is 1000. So we want to repeat this again. It will happen only once, it will exit the if condition, and now curval has crossed 1000. It is now 1001, 2, 3, like this. So to keep it less than 1000, we will minus it with the pre-val, okay, that we defined here. Initially it's 0. So initially when curval crosses 1000, the state toggles, and then we make pre-val is equal to curval. In this way we make sure that the previous val is curval when we leave this if condition, and now this holds 1000 and this is going above 1000, so the difference will be less than 1000. And when it crosses 1000, that means when this becomes 2000 and this is still 1000, this condition becomes true, it's become greater than TP, the state toggles and the LED turns off. Okay, and this way we achieve the blinking state. Now let's upload this to the Arduino Nano. Make sure that it's connected to the proper COM port. The board is selected. So as the code is uploaded, and you can see that the LED is blinking with a delay of 1 second. So this is the alternate logic. We can take modulus curval mod 1001. We have taken 1001 because on 1001 this will return 0, and after 0 return 1, 2, 3 all the way to 1000. So when it becomes equal to 1000, we know that 1 second has passed. We'll toggle the state. Okay, now we don't require this, so I'll upload this. And yes, this logic also works. The LED is blinking with a delay of 1 second. So in this way we saw how to blink a LED using the millis function, and this type of delay is called a non-blocking delay. So whatever lines we write here after the if condition, these are also executed and the program just stops here. Okay, so in this way we saw how to implement non-blocking delay. I hope you found this video useful. Like and subscribe to my channel for more interesting electronics video. Thanks for watching.